double triangle proof in the notes, and like I said before, we could take it a different route and use 3 sets of congruent triangles if we wanted to, but that's not the route we're taking on this video. Again, kind of how I think through what I'm planning on doing when I'm doing these proofs. They are telling me that AC is congruent to BC, and so AC is this entire segment here, and BC is this whole segment over here on the right. And so if I'm going to use this given, I need to be using a triangle that has this as a side of it. Very important to do that. And then they also said that AD, which is over here, from here to here, is congruent to BD, which is from here to here. And so those two given pieces of information tell me that I'm going to be using a triangle that has those two sides. So I'm going to sort of outline the triangles that I'm using right now. So that is a side and this blue segment, and so that means, you know, this whole yellow triangle is one triangle that I'm going to show congruent to the other large triangle on this side. Make that one sort of striped. So I'm going to be proving those two triangles congruent first because of the given. Just the given is going to help me with those two items. What I want to show is that angle CED is congruent to angle CFD, which is in the top little bitty triangles. And so my goal is to kind of get into those triangles, but as we get going, you'll see that we won't have enough information to use these two triangles in particular. We're going to end up using these two bottom triangles. They kind of make this bow tie shape, so 1 and 2, angles 1 and 2 are going to be vertical angles, and we'll be able to use those. We actually have more information available for these bottom triangles than the top 2 small triangles, and that's why we're going to go the route that we are going to take. So let's start going through here, and they have a lot of this filled in for us. So we've got our 2 givens here, and our reason is given. And then, since these triangles are touching, and in this picture, the place that they're touching is this segment right here, and that's a side of those triangles, and so we're going to say that they share that side. So CD is congruent to CD by the reflexive property of congruence. And so right now we've got the this side congruent to this side. We've got these with the 2 markings, and so I'll put 3 markings right there. And now you can see that every side of the triangle is marked. So we're going to have side, side, side. Congruence postulate be our reason why the triangles are congruent. Now, this is the part where we would decide, did we want to go for which triangles next? If you were thinking, you know, like I was, that I wanted to use these top 2 small triangles, I might be wanting to use the angle here and this angle here. But notice that that information and the fact that they share this side are only 2 pieces of information, and we're not able to come up with any more information. So I can't go that route in my solving. So I had to think of another way to do it. So then I noticed these triangles at the bottom that are making this bow tie shape, and I'm going to kind of outline them in a different color of highlighter for us here. So right here, we've got these triangles that make this sort of, like I keep saying, that bow tie shape. And so they have some vertical angles here in the middle that we're going to be using. And so I'm going to be able to get these vertical angles, and I've already got this side here. So now I need a piece of the yellow triangle to use, because I know I can use the corresponding parts of that yellow triangle. And so right now I'm just kind of deciding what is the part that I need to use with CPCTC. And so in these teal triangles, the only part that they have that the yellow triangle also had, of course it has AD and BD, but that's already marked, so we already had that, is that we could use these angles at A and at B. And so then we would be able to use angle side angle for those two triangles, those smaller triangles. So we have angle A and B congruent, CP, CTC, but that's why we picked A and B. Then we had already said that 1 and 2 would be vertical angles, so here's the statement: 1 and 2, vertical angles, congruent, because now we're going to start using those two angle pairs. And so we've got two angles here, and of course they already had AD and BD that we're using, so we can say that those triangles are congruent by angle side angle, because we have two angles and the included side, and that's angle side angle congruence postulate. And so now what we did was, since we know that these teal triangles are congruent, we are going to use this angle here that's next to the angles that are our goal. And we know that these angles are congruent because of CPCTC. The corresponding parts of congruent triangles are congruent. And since we know that those are congruent and they're linear pairs with these others, we're going to be able to use the fact that these are supplementary over here, these two angles at E, and the two angles at F are also supplementary, and the ones where I put the arrows are congruent, so we can use congruent supplements theorem to get to our last step. And so what we're going to do is we're going to say that these angle pairs are supplementary by the linear pair postulate. So I'm going to name them, and I have to use 3 letters. So I'm going to say angle AED, and I'm going to just say sup, so it's supplementary to angle CED. I like to name it like our goal is for it to look. And then I can also say that angle BFD is supplementary to angle CFD. And my reasoning here is the linear pair postulate for why those are supplementary. Sorry, my email's going crazy on me. And now that we have these two sets of supplementary angles, and we know that AED is the congruent angle to BFD, we can use the congruent supplements theorem to say that angle CED is congruent to angle CFD. So this is the congruent supplements theorem. And then there's just one last thing just underneath this proof, and it says in the diagram above, if you're given that AC is congruent to BC and that angle A is congruent to angle B, can you prove that triangle AFC is congruent to triangle BEC? If so, by what postulate? And so down here I have kind of recreated the image with these overlapping, and I made them overlap so I can pull them apart. We find triangle AFC I have in teal, and triangle BEC I have in purple. Notice that they overlap and share angle C. So we're gonna mark C congruent. We're also gonna mark what they had said, which is AC and BC and A and B. So let me pull these apart. Remember again that they had shared angle C. So let's go ahead before we forget and mark that they had shared angle C. Those were congruent. They had told us in the given that AC was congruent to BC, and they had also given us that angle A was congruent to angle B. And now that we've drawn them separately and we've found that they shared angle C so that those were congruent to themselves there, we are able to say the triangles are congruent. We can see that it's two angle markings in the side in between, so our reason would be angle side angle congruence postulate.